Good day, folks. This is video number 15 in the playlist that's devoted to motion design application in 3D experience, but it's the playlist that deals with kinematic problems. Now, this is called ellipse generating mechanism, and as, for example, this rod, this orange rod turns, you'll see in a minute what the parts are. The tip of the rod will actually traverse an ellipse. It generates an ellipse. Uh, so the parts that I'm making are like that. There are two parts like this, two blocks will hold like that, and they travel in these slots. And then there is an arm here which goes into these holes, and that makes the mechanism. Uh, I will be using inches here, although it's totally irrelevant. Uh, so I'll be using inches. Now, this problem was done in another playlist which is devoted to mechanical systems design, and you can find it there. But remember, motion design is different from mechanical systems design. So this is going to be a video that's different from what you have already seen here in tutorial 16. Now, it was also done many, many years ago with the CATIA V5, and you can find the link here. So let me go ahead and make the parts. Here is our interface, 3D Experience interface. Okay, one thing I forgot to clarify, and that is, notice that the title of this video says joints created with manual markers, because it's possible to create the joints as engineering connection or create the constraint as engineering connection in assembly design, and when you move into the motion design, these engineering connections are converted into joints. That is not the approach that I'm taking. In fact, the approach that I just mentioned, creating engineering connection, is even more straightforward. However, I want to use the idea of markers to manually create joints. Okay? All right, so let's go ahead here. I already changed my units here. Let me first insert that track. So right click, or I'll call it base. Okay, so insert 3D part. Okay. I'm going to be consistent with those dimensions that I have in drawing, although that's not really critical. So let me call this thing the base. Base and base. Okay, let's go make it. So basically it's a box with those two slots in it. So let me go to part design. Design. Okay, on that horizontal plane, we'll sketch. Let me sketch, just so that my life is easier, a center rectangle like that, and let me dimension these to be 10 inches and 10 inches. This is 10 inches. Okay, and this is also 10 inches. Okay, exit. And then pad it. All right, so I want to pad it by 1 inch so that it looks exactly like what I have in the slide. Now on that vertical plane, I will sketch. Let me see now, I'll sketch, yeah, something like this. I'll clean it up in a minute. This is going to be the track, and let me make it exactly the width of one inch. So let me see now. I'll make this thing 1 inch. Okay, and then put it exactly halfway between these two. So from here to here, exactly halfway, 0.5. Very good. And that's pretty much it. Exit. And then we let me pocket it. I pocket this symmetrically, and let's move it until it reaches the end. Now I want exactly the same thing on the other side, and to make my life easier, what I'm going to do, I'm going to actually create a circular pattern of that. You'll see why, because I can do exactly the same thing, but I'd rather use a circular pattern. So transform a rectangular pattern, we make a circular pattern. Let's see. And the thing that I want to pattern is not the current solid, it's just that pocket. And the reference element is going to be, well, you can select the z-axis, okay? And I want two of them, and let's make it 90 degrees. Yeah, I mean, I could have just made another pocket. That's fine. So this is going to go all the way, we go all the way to the top, and then we insert our blocks. So let's do this. Right click, insert 3D part. Let me call this thing block. These are the things that travel up and down those slots. Block and block. All right, I'm going to change the color of it to, I don't know, maybe this. That's fine. It's just the box with a hole in it. So let's go to the part design. Okay, so on a convenient plane, on that plane, I'll sketch. Have to go to the part design, of course. On a convenient plane, on the XY plane, we'll sketch. Okay, why don't I make a square 1 inch by 1 inch? Okay, 1 inch. All right, and then just make my job easier, I'm going to draw a circle here. Let's clean it up. So distance from here, I want this thing to be distance from on this. Okay, so the distance, let me see, exactly halfway in the middle from here to that center point, 0.5. And same thing on this side. There are other ways of doing it, but also 0.5, that's exactly halfway in the middle. And the radius of that, I want to make it 0.25. Yeah, these are totally irrelevant for the purpose that we have in the tutorial. Exit. Okay, and then we pad it by 1.5. 1.5. And I need two of these. Now, there are different ways of doing it. Obviously, you can copy and paste this thing, or block. You can create a multi-instantiation. Okay. And how many is that? We want two of them. Okay. So just two of them. That's good. There we are. Let me move this thing so I can see it better. The color of this did not change, but that's okay. Properties, I'll change it manually. There we are. Now I want to move this thing, so let me do a manipulate, or you can use the compass if you want. Manipulate, translate along this. Okay, so let me get this thing and move it there so I can see what's going on. Very good. So that takes care of that. Now, then I'm going to do the rod. So all the way to the top, right click, insert 3D part. Call this thing the rod, properties. You see, properties. We'll call this thing rod. Yeah, I called it rod, I'm not sure. Rod or arm, either way, call it rod. And the color of it, I'm going to make maybe orange. Let's go make it. Part design. So I want to make something uh, like this. Okay. So on that plane, I will sketch the actual size of that does not matter. Width of that does not matter. So I'll make it like this. Okay, length of it 15. Okay, and then I'm going to make two circles here. Okay, so one like that, and 1 inch away, that'll be 1 inch away. Okay, this radius 0.25. Okay, and the distance from that point to this point is 1 inch, according to the drawing. And then I want another circle just like that. You can copy it and translate it, whatever, but that's okay. I'll make another one. This is 0.25, and the distance between the two centers. These geometric dimensions affect the size of that ellipse, but we're not interested in that issue. There we are. Exit. Okay, and then pad it. If I pad it, there's going to be two holes here, but you know, I can multi-pad. So do a multi-pad. There's three basically curves here. So this one is the actual rectangular piece. So I'll make it maybe 0.25. See how it looks like. Yeah, that's good. These two are the holes. So which I don't want them to be whole. They're whole because they're 0. So maybe I make it 0.5. And same thing with this one. 0.5. There we are. Okay. Yeah, so that's pretty much it. Let me also change the, yeah, that's good. Now, notice that I said that we can create engineering connections and then go and convert them into joints, but that's not the approach that I'm going to take. By the way, I'm going to change the color of that thing to yellow. Very good. Okay, so that's pretty much it as far as making the parts is concerned. And now we're going to go to motion design. Motion design, let me find it. There we are. Now, as soon as you go there, what it does, it creates mechanism. However, because there are no engineering connections here, there are no joints, and you have to create the joints yourself. And I'm going to use markers to do that. You'll see what I have in mind. So we say OK. All right. Let's see what we've got here. This is a symbol for gravity. So gravity is active, but it's totally irrelevant to us. because we're going to be doing kinematic analysis. There are several bodies created. Ground is ground. There is the base, and this is the block 1, block 2, and rod. Okay, so uh, what I need to do is to create markers, because markers already are created and they're on top of each other. Each one of these pieces has a marker. Each one of these parts have a marker. You can see that. Each one of them has a marker. Even the ground has a marker. But they're sitting on top of each other. Many of them are sitting on top of each other. So, well, I'm going to create manual markers. So what do I mean by this? So first of all, let me go ahead and create a marker for the base. And what I'm going to do by geometry, and by geometry, what that means is that I want along that direction. So Z, see that Z is going to be in this direction. X going like that, Y going like that, Z in this direction. No problem. That's this slot. And then another one that side. Another one this part. Again by geometry. So another marker in this direction. So Z is along the direction that I picked. I'm going to create markers at the corners of these or these edges, it doesn't matter. So marker for this piece by geometry, that edge, so it creates it right in the middle. Again, Z is along that line. And one more, so marker, well, actually, let me see now, for the same thing, you'll see what I needed by geometry, and I'm going to use that circle on the top, so it's going to put a marker there. Z is along the whole direction. I'll do exactly the same thing with this fellow. So marker, this body by geometry, there, puts it in the middle, and one on the top. This piece by geometry, that circle on the top. Say okay. And now I need markers for these circles. So I go to marker, this piece by geometry, one of them for that circle, all right, and another one for the other circle. Marker, this piece. Believe me, if you were doing it with engineering connection, it would be a lot faster. But these markers are very useful, and we have to practice with it. Okay, so I need everything that was required here. So let's go create a joint. So we go create a joint. Okay. The joint fix, the body is the base. That's going to be fixed. Let's do a prismatic between this block and one of these slots. So here's how we're going to do that. We go create another joint, prismatic, between, for example, let's put this and put it in that slot, okay? We may have to orient it correctly, so we go here to there. Select this. Yeah, and then say okay. Now notice that later on I can translate this thing so it looks nicer, it looks entrapped in the middle. So let's do that. Let me do that right now. See? Okay. Just to show you that it ended up in the right spot. Do exactly this. Let's do another prismatic join. So join, prismatic between this marker and that marker, except that it is not in the right orientation. So what I can do, I can go to this choice here, this box, right click, edit marker by geometry, and flip this, and then say OK. The only disadvantage of marker is that you may have to fool around with it a little bit to get it to work. Now, we're going to insert these things into those holes. So let's do that. These are revolute joints, so let's go and do a revolute. Revolute between, for example, this marker and that marker that we created here. One of them, it doesn't matter which one. Okay. And once again, you want to flip this, so let's go ahead and do it like that. Flip the arrow. Okay, so that's good. And let's put this guy in that hole. So another revolute between that marker and this marker, and edit, flip it, and then we say OK. Okay, this one is fine, except that fellow is supposed to be traveling along that path. Okay, so let's leave it like this for now. See what's going on. Let's go ahead and do the kinematic player. Okay, so let's look at it. You see? You see? This one is fine. Fine. All right, very good. So we say OK. Now, it's kind of deceiving the way it looks like. It looks like we don't have our mechanism, but you can see that as soon as I click on the mechanism player, it kind of adjusts itself the way it's supposed to go. All right, reset. Okay, now let's put some physics behind this thing. Suppose we pretend that we have a motor inside of one of these which turns continuously. So let's go ahead and make a driver for that one of these revolutes that we created, say this one, and let's give it a constant angular velocity. So you click on this icon. Okay. We want the velocity, angular velocity, to be constant, and let's make it, I don't know, maybe 2 radians per second. Okay, so we say okay. Now, before we run it, I'm going to go here and remind you that we have a step here. This is okay, close it. It's dynamic, but really it doesn't matter. I want kinematic, okay? And if you want velocity and things like that, you'll be able to plot it. Just make sure you ask for it. Position, velocity, acceleration. It's okay. And that's pretty much it. Let's run it. The default duration is, I believe, 5 seconds. Well, we'll see. So let's go ahead and run it. We can have a preview, by the way. Here's a preview. Let's give it time. Yeah, fine. Exit. Let's go and simulate simulation. Run it. Wait until it finishes. Close it. Select the result, the last file. You want to do animation, select this. Go to result. Here's the animation. And play it for 5 seconds. Duration of the simulation. There we are. Okay, good. Now, if you want to plot the trace of this point, so let's go find out where the trace is. It's simulation. I think it's in mechanism. Yeah, in Mechanism tab, you go and select the, what is that, geometric trace. You select a corner point, and then you say OK, and then you have to run it. There we are. This is an ellipse. Now, if this point happened to be exactly halfway between the two ends, that would be a circle. And you can always check this. Select this thing, not the probe. Select the file, animate, play. The tip traverses an ellipse. That's pretty much it. Look, it was probably more straightforward if you created your engineering connection at the assembly and then they get automatically converted into joints. Now, I've done many videos like that in this playlist where actually that's the route that I took. However, here I decided to use the marker. Okay? You just have to fool around with the marker and make sure they line up the way they're supposed to. All right, folks, good luck.